This particular video, we're going to have a discussion on how to perform integrations involving 1 over f of x. For instance, if you are going to be given a question whereby we are supposed to integrate this expression, integrating 1 over x with respect to x, this one you cannot be able to use the normal integration we usually do or the integration that we did. Of course, if you don't do it like this, don't make this mistake of saying this is the same as integral of -1 with respect to x, and then you say therefore this is going to be x -1 plus 0 over -1 plus 0. You see now this one is very wrong. You cannot be able to. Just show you how you can be able to integrate this. Whenever you are integrating an expression like this, this means it's going to reduce to ln of x. This is absolute value of x, then plus c. This is what it reduces to. Now, whenever you are going to have an expression like this one you are going to treat it first so that you make it this way. And you are going to take 2 out of the integral. You'll have 1 over x with respect to x. Then at that point, when you integrate this, you can see we have said it becomes this. Then we shall say this is 2 ln of x absolute, then plus c. Now, we want to have a general relation so that we can be able to use it in order to perform different expression. A situation whereby you are having an integral of 1 of f of x with respect to x, meaning that f of x is a function of x. You are going to say that this is going to be, you are going to differentiate this, you're going to differentiate this function, and you say 1 over d of dx of f of x. So you are going to differentiate this, but you shall say 1 over that, and then you say ln of absolute values of f of x, then you are going to say plus c, like that. So I'm going to show you how you are going to use this relation I've told you here so that you can be able to perform integration of this one. So let us go. Now, we have said the first thing that you're going to do is to differentiate this function that we have here. Differentiating 3x plus 1, what do you get? Yes, we are integrating, but you are going to differentiate first so that you can have what you are going to put 1 over this part. So differentiating this, we are going to get 3. So we shall say 1 over 3, then ln of 3x plus 1, then plus c as that. Now that become right. The next question is for 1 over that. So meaning that this one we have to treat it first, so that because we want a 1 at the numerator, yes, we need to do that. So we are going to say this integral we are having here becomes what? Becomes 4 integral of 1 over 1 plus 2x. So that is the first thing that we are going to do at that point. I think that pen is faint. Now, in order to integrate this, first we're going to work on this so that we have 1 over a function, then we integrate. So meaning we are going to take 4 out of the integral, so this equation becomes, this integral becomes 4 integral of 1 over 1 plus 2x with respect to x. And since we are having a function of x at this given point, it means we are going to differentiate this. We divide it by 4 here, and this is going to be equal to 4 over, differentiating this, we are going to get 2, then ln of 1 plus 2x then plus c, which is going to simplify to 2 ln of 1 plus 2x plus c. Now, at this point of time, I want to show you how you can be able to integrate this question step by step. Now, number one, we need to prepare this question so that we can be able to integrate it using this relation we are having here. First, we have to take 3 outside the integral, and then we shall have 3 integral from 1 all the way to 4, and that translates to 1 over 4 minus 2x with respect to x. That is the first step. Now, step number 2, you are going now to differentiate this part that we are having here. You are going to differentiate the denominator the way we said, then divide by. So we're going to have this as 3. Differentiating this, we're going to get negative 2. Then we shall say 1 over negative 2. Then ln of absolute value of 4 minus 2x. Then we shall write the limits from 1 all the way to 4 there. Now, since this is a constant, since this number here is a constant, and it's not going to be affected by these limits that we're having at this point, what we're going to do is to take that constant out so that our expression can be simplified. So this is going to be negative 3 over 2 into bracket ln of 4 minus 2x, like that. Then the limit remains to be 1 all the way to 4, like that. Now this one, we are going to substitute. We are going to substitute 4 anywhere we have x, and then we are going to substitute 1 anywhere we have x here. Then we subtract them. So meaning we are going to have our expression as negative 3 over 2 into brackets. Substituting 4 here, it will be 4 minus 2 times 4. This is going to be minus 8 here. So 4 minus 8 will be negative 4. So the first part will be ln of negative 4. But remember, we have absolute signs there. Then we're going to say minus. Substituting 1 into this, it will be 4 minus 2 times 1. That will be 4 minus 2, and that is going to translate to 2. So this is going to be ln of 2, like that. Like that. So meaning that we have our expression here. So why are we not including the constant? See, the way we were doing in this kind of expressions, we are not going to include the constant because we are having the limits. When the limits are there, don't include the constant because it will cancel out eventually. And this absolute sign means if this is a negative, we are going to treat it as a positive. That's why we are having the absolute values at this given point. So meaning we are going to have minus 3 over 2 into brackets ln of 4 minus ln of 2. Now, from the laws of logarithms, I need you to remember that if you are having ln of a minus ln of b, this translates to ln of a over b from the laws of logarithms. So equally here, we are going to simplify that to a single log, which will mean that we are going to have minus 3 over 2 ln of 4 over 2. 4 over 2 because of this minus sign, which will mean, and our expression is going to become finally minus 3 over 2 ln of 2 as the final answer to this. If you have gotten value from this video, consider subscribing so that anytime I'm going to upload the next tutorial regarding integration, you'll be notified.